In the previous video, we introduced the Gabriel synthesis, the principles behind it, and the general recipe that you use each time you do it. It's a way to make an amine from an alkyl halide using an SN2 reaction. And so anytime you see an amine, you should think, I can make this using the Gabriel synthesis. And the recipe that we worked out in that last video was this one right here. We said every time you do a Gabriel synthesis, you'll start with phthalimide that has this alpha nitrogen. Nitrogen is the alpha atom. It has a hydrogen on it that's acidic. Every time you do the Gabriel synthesis, you rip that alpha hydrogen off with a base like potassium hydroxide. And then this nitrogen has a negative charge on it and can act as a nucleophile to do an SN2 reaction. So all you have to do is add the alkyl halide you want, and you'll create a bond between the carbon and the nitrogen. Then you release it from the phthalimide, from the claws of the phthalimide molecule, by doing an acid-catalyzed hydrolysis or by using hydrazine. So we discussed all of that in detail last time. And this time, all we have to do is just remember this recipe and write in the specific alkyl halide that we want. To do that, to get the right alkyl halide, all you have to do is take the molecule you're interested in, erase the nitrogen, and where it was, add a leaving group. And it could be a chlorine, could be a bromine, could be an iodine, any leaving group. And there it is. That's your synthesis for this amine. You'll end up making the amine that you wanted in the first place. So you can make any amine by doing a simple SN2 reaction, just starting out with phthalimide. You just have to turn it into a nucleophile by ripping the alpha hydrogen off with potassium hydroxide. And then you do hydrolysis or use hydrazine to release it from the claws of the phthalimide molecule. In this next example, we see an amine, and anytime you see an amine from now to the end of your days, you'll want to say, I could make that from the Gabriel synthesis, using the Gabriel synthesis. And the general recipe for the Gabriel synthesis is this here. Now, if you see this and you think, all I have to do is memorize those random letters and numbers, I guess you could do that, but why? It's more effort and it's less meaning. You can remember this more with less effort, and it would be more meaningful to you. It would help you to learn principles that you can apply and concepts that you can apply to other classes. If you go back to that last video we watched, and you review the role that all of these things are playing. In this case, all we have to do is replace the alkyl halide with the specific alkyl halide, the general alkyl halide we have in our recipe, with the specific one that we want here. So you take the molecule that you have, erase the amine, and just fill in whatever leaving group you want to use. Here I'll use an iodine. It could be chlorine, bromine, iodine, any one. And that will give you the amine that you are interested in. So phthalimide, you always start with a base like potassium hydroxide, always rips off that alpha hydrogen, turns the nitrogen into a nucleophile. You have to think about the right alkyl halide you want to do an SN2 reaction with to create the bond between the nitrogen and the carbon there. And then you release the nitrogen from the phthalimide either by using acid-catalyzed hydrolysis with hydronium or hydrazine. Okay, let's think about C. In C, you have an amine, and now, from now to the end of the earth, or the end of your days, you'll see an amine. Every time you see an amine, you think, I could make that using the Gabriel synthesis. Let me just walk over here to my chemistry shelf, and I'll take phthalimide down, and I'll mix it in with some potassium hydroxide. Mwahahaha. That will rip off that hydrogen on the alpha position and turn this nitrogen into a nucleophile. Then I can do an SN2 reaction with an alkyl halide to make this specific amine. All I need to do is take my amine and change the nitrogen in it to a leaving group. A leaving group, for example, like bromine, really any of the halogens, chlorine, bromine, or iodine, And then my nitrogen nucleophile will attack this carbon, kick the leaving group off, will form the bond between the nitrogen and the carbon that we need in the amine. And as a third step, we can release the nitrogen from the claws of the phthalimide by doing an acid-catalyzed hydrolysis or by using a hydrazine. Ultimately, what we get is the amine that we want. All right, let's do another one. So here you see an amine. You see an amine and you say, what? The Gabriel synthesis. The day has come for me to use this reaction, this valuable reaction that I've learned. And so you can take that amine. You'll always start with phthalimide. Whoa. You'll always start with phthalimide. You'll always rip that alpha hydrogen off with a base like potassium hydroxide. And then you'll always add an alkyl halide, but the specific alkyl halide you add will depend on what specific carbon chain you want to make. So instead of, well, you just take your amine there, and instead of the nitrogen, erase that and add in a leaving group, something like chlorine, bromine, or iodine. So what happens is the base rips off the alpha hydrogen. The nitrogen turns into a nucleophile. It swoops in, attacks the carbon here, kicks the leaving group off in a classic SN2 reaction. And now you have the bond between the nitrogen and the carbon. You just have to release the nitrogen from the claws of the phthalimide molecule, and you do that with either acid-catalyzed hydrolysis, that nucleophilic acyl substitution reaction, using hydronium. It just takes a little time, or you can do it faster with hydrazine, either one. In either case, you will end up, making the amine that you always dreamed of. And so here, this really builds on what we talked about in the last video. In this video, it's just an application. You can see how once you really have mastered that recipe for the Gabriel synthesis, and I strongly encourage you to understand what the mechanism for this, although you don't have to draw it, it will turn this reaction from random letters and numbers and structures into a story full of characters that have a similar personality as other characters you've seen. For example, diethylmalonate in the malonic ester synthesis. And you'll see a unity where somebody without understanding would just see a random variety. So I strongly encourage you to go back, understand the principles behind this, but you can see that once you know this recipe, it's really simple to apply it and figure out what alkyl halide you need in order to form any amine. And think of the power of that every time you see a medication that has an amine in it. You'll remember the Gabriel synthesis.